This is the earliest heating pad we made. This is an etched sheet. How is the etched sheet made? Just like our circuit board, use a relatively thick and hard sheet, TP sheet, and plate a layer of aluminum and copper mixture on it, and then use the effect of laser engraving to carve out the circuit to form a resistance loop. This is the earliest carbon fiber. The quality of carbon fiber produced in China before was not up to standard, including the quality of domestic products now. All that can be used is turned to military industry. It will break easily when it is alone, because carbon atoms are hard and brittle, so it is made into this kind of braid, and then 2 copper strips are woven in the middle. This method is not tear-resistant, not washable, and not bendable. The earliest second-generation heating sheet is stainless steel wire, which is a metal wire, and uses metal for power supply. Later, it was found that it is easy to rust and oxidize, causing point heating. Later, this conductive fiber was added to the market, reducing the content of stainless steel wire S316, thus reducing the chance of rusting. But if it is not encapsulated, it will rust, so we will do encapsulation later. This is the encapsulated heating sheet. After the development of the first 2 generations, we gradually began to find some sources of carbon fiber from Japan, because it is easy to transfer to military use, and it is currently banned from sale to China, and now carbon fiber is used in a large amount. Now the head is basically made of this kind of carbon fiber. Its advantages are tear resistance, folding resistance, no rust, and water washing resistance, and its heat conversion efficiency is the highest. The infrared rays it produces are closest to the infrared rays of human skin, so it is more easily absorbed by the human body, so they are also called far infrared. After the second generation, we have now developed to the third generation. The third generation is basically surface heating. As early as 2014, we had this kind of graphene power generation. The molecular structure of this kind of graphene is unstable, so it must be attached to a relatively hard medium, such as PPT. So he plated the copper strip on one side and compounded it on the graphene film on the other side, and then the two were made by hot pressing. But it is also not folding, bending, or water washing resistant. After improving the graphene, we got the carbon nanotubes we have now. This nanotube is made into a tubular structure on the graphene, and its molecular structure is very stable. But there is a drawback, which is the way we connect it with the wire, because it is a surface, and the wire is a wire. So far, we have done a lot of tests on the connection between the wire and the surface, and none of them can survive 30 washes. This is the latest silicone hairpiece made by our company. It is printed with PDCL, and it also heats the surface. At present, its performance is better than that of carbon nanotubes and graphene. It solves the problem of connection, because the silicone wire and the silicone sheet are of the same component, and can be effectively fused together.